So we are, again, just like yesterday, we talked about it yesterday. We worked exact trig ratios yesterday, but when we did exact trig ratios yesterday, we talked about, okay, how do we go about doing them if we have an angle measure? So just kind of a quick review. This first one that we have is the sine of negative 120. So we're going to go ahead and give the exact trig ratio for the sine measure of an angle that's 120 degrees. Okay, so if you remember yesterday, the first thing that we did was we went ahead and graphed the sine of negative 120. So we start in standard position, go clockwise. 90 and negative 120 sits about right there. So kind of label that real quick. That was kind of step one. Step two, then, we took and we drew a vertical line to the x-axis. So there's our x-axis, and that x-axis takes it up to negative 180 degrees. So the next thing we had to find then was we had to find what we called the reference angle. The reference angle is that angle right there. And that reference angle is the angle that we're going to use for opposite hypotenuse and adjacent sides as well. So it's at negative 120. It's got to go to negative 180. It's always going to be positive, of course. So that's a 60-degree angle. So we know we're good because you said you had to have one of three angles in there. You either had to have a 60-degree reference angle, a 30-degree reference angle, or you had to have a 45-degree reference angle. And if you didn't do that, you had something wrong. So then we went ahead and just finished up the labeling. So we have a 30, 60, 90-degree triangle. And now we label the sides according to our ratios. The side opposite the 30 degrees is 1. And because it's going to the left, it's going to be negative. The side opposite the 60 was the square root of 3. And now because it's going down, that's going to be negative. And the hypotenuse is going to be 2. So now when we're talking about the sine ratio, we can go ahead and do that now. Sine is opposite over hypotenuse. And again, remembering that we're going from our reference angle here, 60. So opposite of 60, the furthest away is the negative square root of 3. The hypotenuse is 2. So then we've got our solution, the negative square root of 3 over 2. And that's our sine ratio for negative 120 degrees. And that's what we talked about yesterday. Today, what we're going to work on is we're going to work on finding the exact trig ratios for like 5 pi over 6. And how do we go about doing that? So my suggestion to you, 5 pi over 6, do you know exactly where to put it? Probably not. But my suggestion to you, and the easiest way to kind of do this, and there's other ways you can do this, but the way I kind of like to say is, let's change this 5 pi over 6. Let's change that into degrees, because we know where degrees go. We can graph degrees. So remember, to change something from radians to degrees, you multiply by 180 over pi. So when you multiply this by 180 over pi, pi's cancel out. 5 times 180 is 900. And get 900 divided by 6. And you get 150 degrees. So now we know that cosine of 5 pi over 6 is going to give us the same thing as the cosine of 150 degrees. So now we can go through the process we went through yesterday. You draw your coordinate plane. You sketch 150. Draw your terminal side. Make sure you draw a vertical line to the x-axis. Okay, so I was at 150 degrees. To get to there is 180 degrees. So that makes our reference angle 30. So it's good. So we've got a 30, 60, 90. Label the sides now. The side opposite the 30 is 1, and it's going up, so it's going to be positive. Side opposite the 60 is the square root of 3, and it froze up. There it comes. Right, go. Yes. Square root of 3, but that's going to be negative. Maybe. Come on, you can do it. And then the hypotenuse is going to be 2. Here in for 1 second while we get this to work again. Netflix. Watching Netflix. Now everything appears. So now we have to talk about, okay, what's cosine? Cosine is adjacent over hypotenuse. So our adjacent side to our reference angle is a negative square root of 3. The hypotenuse is 2. And there's your solution. Same as we had for the sine of 120. Any questions with that one? So really this becomes about just kind of turning them into what we did yesterday. Taking it from radians to degrees and then follow the same process. All right, let's look at the next one. Let's do the tangent of 7 pi over 4. So what am I going to do first? Change it to degrees. So 7 pi over 4. What do I have to multiply it by to change it to degrees? 180 over 180 over pi. Pi's cancel out. Calculator, 7 times 180 divided by 4. It's 315 degrees. So we've got 315 degrees. So we can create our coordinate plane. There's our coordinate plane. 90, 180, 270, 315 is in there somewhere. Draw a nice big terminal side. Vertical line. This is 315. Where I drew my vertical line to is 360. What's the difference between 360 and 315? 45. So we've got a 45, 45, 90. So sides in a 45, 45, 90. The legs are 1. And that's going to the right, so it's going to be positive. That's going down, so it's going to be negative. So negative 1. Hypotenuse in a 45, 45, 90 is always the square root of 2. So our tangent ratio then, get this out of the way. The tangent ratio then is going to be opposite over adjacent. And again, it's from our reference angle. So opposite is negative 1, adjacent is 1. So you get negative 1 over 1, which is just equal to negative 1. And you're done. That's the exact trig value of 7 pi over 4. Any questions with that one? All right, so I want you to try this one on your own. Secant of 5 pi over 4. Write the exact trig ratio for the secant of 5 pi over 4. Okay, if you peek up. So step 1, change it to degrees. It's 225. Draw a 225 degree angle. And again, I put 225 down there. And then when I draw my vertical line up to the x-axis, that's it to the 180 mark. So that I can find my reference angle 45 with -1, and square root of 2. Secant is hypotenuse over adjacent. Hypotenuse is the square root of 2 over -1, and then that just reduces to the square root, negative square root of 2. Okay. So that's exact trig ratios. Both degrees and radians. Yesterday was degrees, today was radians.